Hello, my name is Adrian Rodriguez and I will be presenting my statistical method presentation on network analysis. Now, after reading the contents of this fantastic book, I realized that this form of statistical analysis is not really used for research purposes. Instead, it is used to predict outcomes and measure probabilities involving networks. I could be wrong, and I'll be honest, this book was extremely hard to read, and I had to do a little bit of outside reconnaissance to get a better idea of what network analysis really is and how it relates to statistics. And I'll show you those later as the presentation goes on. So, what is a network? Here are some examples of what makes a network. We've got transportation, social networks, and computers. Transportation, two cities connected by a highway. Social, Facebook friends, Twitter followers. And on a computer network, a little bit more complex, but computers are connected via the internet, essentially. So we know what a network is, but in the stats world, we need to delve a little deeper and define it. Here we have nodes and edges. A node is a centralized point, and it can be a person, place, or a thing. An edge can connect two nodes together, like this. Now, why is network analysis necessary as a statistical method? Well, according to David Noak and James Kuklinski in the Sage University paper, individual actors are depicted as making choices and acting without regard to the behavior of other actors. Its first essential insight is that any actor typically participates in a social system involving many other actors who are significant reference points to one another's decisions. Its second essential insight lies in the importance of elucidating the various levels of structure in a social system, where structure consists of regularities in the patterns of relations among concrete entities. This is what got me thinking that network analysis might be more useful in predicting outcomes or determining cause and effect. The book also expresses its importance in the social sciences, which we are currently studying being in the criminal justice department. So here's an example of a small network in the medical field and how things flow. As you can see, the doctors, nurses, patients, and receptionists are all nodes, and their relationships to one another are represented by the edges, or lines, that link them. This is called a graph. Whenever there are nodes which are connected by edges, it becomes a graph. Pretty simple, right? Well, let's take a look at this. Next, we have another graph depicting money flow in a local government. This is a helpful graph for those who are in public service and deal with budgets or making spending decisions. The authors also note here that the path distance is very important. There are short paths and long paths, and the distance between each node is significant. Last, we have some equations. This is where it got really confusing for me. The key assumption in this operationalization of structural equivalence is that distance between a pair of actors is measurable in terms of dissimilarity in their patterns of relations with other system actors. If they have exactly identical relations with the others, their distance is zero, and as noted above, they occupy an identical point in the social space. As the pair of actors have increasingly different patterns of ties with the others, they are increasingly more distant from each other in the social space. Conceptualizing a social space in Euclidean terms, the distance between actors I and j equals the square root of the sum of squared differences across all third actors q. I'm sure this is quite simple. We deal with the sum of squares a lot. I know I've heard the term before in this class, and I know it's a function on SPSS, but I tried to find some online resources to help me figure out what's going on or exactly how to do this. I couldn't find anything related to this specifically, but I was able to find a couple of YouTube videos that explain network analysis. Some were very helpful.
Let's pick back up with the example from Apollo 13 that we've been working with. Remember that degree is the number of edges connected to a node. So here Tom Hanks has a degree of 2. There's 1, 2 edges. Bill Paxton also has a degree of 2. Gary Sinise has a degree of 4. 1, 2, 3, 4. And Ed Harris and Kevin Bacon both have a degree of 1.
Others were very confusing to me.
पावर जब v इंटू आई होता है दोनों को मल्टीप्लाई किया आपके पास v इंटू आई v इक्वल टू आई आर है तो आई स्क्वायर आर हो गया ये पॉजिटिव पावर आ गई ये एब्जॉर्ब करेगा आपके पास एब्जॉर्ब.
But I was able to get more information on the topic this way without having to tear up this book. Anyway, I hope you have enjoyed my presentation, and I hope you learned something new about network analysis that you didn't know before.